In this video, we're going to look at how to do a hypothesis test for a mean, and then we'll also look at how we can do this using StatCrunch. So when we are going to do a hypothesis test for a claim about a mean, we need to make sure that we check our two requirements. And the first one says that our sample is a simple random sample. And then the second one says that either the population is normally distributed or our sample size is larger than 30. So for the last requirement, only one of these requirements needs to be met. Now, our null hypothesis, since we are testing a claim about a mean, we want to make sure we use the proper notation. So our null hypothesis would be that the population mean is equal to some claimed value. And then our alternative hypothesis can take one of three different forms depending on what we're trying to test. So we could have our alternative be that the population mean is not equal to that particular number. We could have the alternative be that the population mean is less than whatever our particular number was. Or we could have the alternative be that the population mean is larger than our claimed number. But one thing to keep in mind is that the number that we have up here in our null hypothesis is going to be the exact same value as the number we have down here for whichever alternative hypothesis we end up using. Once we get our null and our alternative hypothesis established, then we need to go ahead and we need to compute our test statistic. Now we're going to have two options here. If our population standard deviation is unknown, which is usually the case, we're going to use the t-distribution, and this particular formula is going to allow us to calculate our test statistic when our standard deviation is unknown. Now, if we do know our population standard deviation, we will use the z-distribution. And so our formula, it has the same general setup, but just some slightly different values in it. We would use the second formula here when our standard deviation is known. Okay, then once you have your test statistic computed, then you have to decide, are you going to use the critical value method or are you going to use the p-value method? So we're going to go ahead and take a look at an example and look at how this whole thing would work out. So for our example, we have a professor finds that the mean of the final exam scores from his introductory psychology class of 46 students is 74.8% with a standard deviation of 7.2%. The psychology department at his institution claimed that the mean on the final for this introductory psychology class is 78%. Use a 0.05 significance level to test if this professor's scores are lower than that of the entire department. So what we want to do first is we want to start by checking our requirements. So the simple random sample, it doesn't really tell us if this is simple random, but we're going to have to make the assumption that the people that are in his psychology class come from a simple random selection, that there was no special requirements to get into his particular class. The second part was that either our population has to be normally distributed or our sample size has to be larger than 30. Well, we have right here that our sample size was 46, so we meet the second part of that requirement, so we are good to go. So what we want to do next is we want to set up our null hypothesis. So our null hypothesis is, what is the claim about our population mean? Well, our claim is that the entire department, the mean is 78%. So we would have mu is equal to 78%. Now, if you get confused as far as which value should be the value in your null and alternative hypothesis, make sure you clearly understand which value comes from the sample. So up here, it tells us that from his class of 46 students, his mean was 74.8. That is our sample. So we do not want that to show up in our null and alternative hypothesis. Okay, now our alternative hypothesis, again, it can take three different forms, and we want to determine the form based off of the phrasing in the question. Now, at the very last sentence here, it says we want to test if this professor's scores are lower than that of the entire department. So because it's asking us to test whether they are lower, we would want to use the less than symbol. So we're trying to decide, is it actually lower than 78%? So that's going to be our alternative hypothesis for this particular example. Now we would have to determine if we are going to use the t distribution or the z distribution. And remember, that comes down to, do we know the population standard deviation? Well, the only standard deviation they give us in the problem here is the 7.2%. And if we read through that, it's implied that this standard deviation came from the sample of his 46 students. So we only have the sample standard deviation. So we would go ahead and use the t distribution. So we're going to do our test statistic using the formula for the t value. So it says I need to take my sample mean, which was 74.8, subtract my population mean. Well, right here I have my population mean of 78. I need to divide that by my sample standard deviation, which was 7.2, over the square root of n, and n is my sample size of 46. So once you plug all this into your calculator and do the computation, you will end up getting a test statistic of negative 3.01 approximately. So this value right here is our test statistic. Now at this point, you have to decide if you want to use the critical value method or if you want to use the p-value method. I'll quickly go over both of them, but after you do several of these examples, you'll have to decide which method you prefer. They will both produce the same results. So now, because our alternative hypothesis here was a less than symbol, just to get a visual of what we have going on here. So we have our normal curve, and I have a left-tailed test. Now, my 0.05 significant level, that represents the area of my rejection region down here. Notice I don't cut this one in half like we do on some of the other ones because it was not a two-tailed test. So if I do the critical value method first, what I would do is I would go to my t distribution, because remember I'm using a t-score here, and I would find the value that's associated with this particular setup. Now, depending on the table that you're using to look up your t distribution, you might get a slightly different value than what we come up with, because some tables have a lot more information in them than others do. So this part right here might be a little bit different depending on the table that you use. Well, when I go to the table that I have and I look up my degrees of freedom, which are going to be 46 minus 1 is 45, and I look up the critical value on my table associated with degrees of freedom 45 and an area to the right of 0.95, I end up finding my critical value to be negative 1.679. Okay, so that's my critical t-score there. Now what we can do is we can compare our test statistic to our critical value. So if I plot where my critical value would land with regards to my test statistic, -3 is going to be down here to the left of my critical value. And now notice my test statistic falls in my rejection region. So at this point, we could then lead to the conclusion that we are able to reject the null hypothesis. So we're essentially saying that's not right. And we have enough evidence to support our alternative hypothesis. So we could say that we have sufficient evidence at the 0.05 significance level to support the claim that this particular professor's final exam scores really are lower than the mean of 78 of the department. Okay, now, so that's the critical value method. If we want to use the p-value method, we're still going to have our test statistic. But instead of going to our t-table and finding this critical value of the 1.679, we're going to look up the p-value associated with our test statistic. So as far as our diagram goes, the p-value would represent the area of the rejection region associated with our test statistics. So we're really trying to find this area for a t-score of negative 3.01. And again, at this point, depending on the table that you're using, or if you're using a calculator, your p-values might be different than what I come up with here. Because with the t-distribution, a lot of times we have to do a little bit of rounding because we don't have quite as much information as what we need. But when I go to my p-value calculator, I end up finding that the p-value for negative 3.01 is approximately 0.0023. Now at this point, in order to make my decision, I compare the p-value to my significance level. So my significance level of alpha was 0.05. That was from up here in the problem. And if my p-value is less than my alpha, I'm able to reject my null hypothesis. And it is the case that my p-value is less than alpha, so I'm going to go ahead and reject the null hypothesis, which is the same conclusion I had from doing the critical value method. So it doesn't matter which method you use, whether you do critical value or the p-value method, you'll come up to the same conclusion with either of those methods. It just becomes a matter of what your preference is, or what you're asked to do for each particular problem. Now, we can do pretty much all of this in StatCrunch also. We would go to the Stat menu, and then you have to know if you're using the Z or the T distribution. And again, that's based off of, do you know the population standard deviation, or do you only know the sample standard deviation? And then for our example, we would do one sample with summary. There is also an option that you might have to choose depending on the information given to you. If you have just raw data values, then instead of with summary, you would choose with data. So let's look at what this looks like in StatCrunch. So I have StatCrunch open here, and in order to do my hypothesis test, I'm going to go to the Stat menu, and then here's where I have Z-stats or T-stats. Now for my example, it was a T-stat because we only knew the sample standard deviation. I was only doing one sample, and mine was with a summary. So when I click on all that, it opens up this box, and then it asks me to input my information. So my sample mean was 74.8, my sample standard deviation was 7.2, and my sample size was 46 students. Then here it says I want to perform a hypothesis test, and it wants me to enter my value for my null hypothesis. Well, that was the 78. And then for my alternative hypothesis, since we had a left-tailed test, we had less than, we want to make sure we select that symbol. Then when I press compute, we can see over here that it computes our test statistic for us, which was the same value that we got, the negative 3.014. And then it also does give us our p-value here at the very end. Now notice the p-value is slightly different than what I had when I was using my own p-value calculator and table. But again, that's because with the t distribution, sometimes our tables are a little bit limited. So at this point, you could continue on with the rest of the process just like we did before.